Let's look at the difference between heat and thermal energy. It can be kind of confusing. So here we have heat, and when you think of heat, I want you to think of it as the movement of thermal energy. In the book, it says the transfer, but same thing. So movement of thermal energy. Now you'll see right off the bat that I'm using the word thermal energy in heat. So it's important that we define what thermal energy is. So let's jump over and do that really quick. Okay, now thermal energy and heat, of course, are related, but thermal energy has a lot to do with the kinetic energy of the particles or the molecules in a substance or an object. So if we're talking about a desk, for instance, which is a solid, we're talking about how fast the molecules are moving. How much, in other words, to be more specific, how much kinetic energy they would have. Which they wouldn't have a lot because they're not moving a whole lot, and that's why the desk keeps its shape. That's why it's a solid. So kinetic energy, again, just is the energy of motion. All right, so how much movement do the molecules in a substance or an object have? Okay, so e.g. desk would have, for example, that's what e.g. means. Desk has low thermal energy, and as a result, it's a solid. So a good example of this is water. Remember, when water has really low thermal energy, it turns into a solid, which is ice. If you increase the thermal energy, then it turns into a liquid water, which we drink. And if you increase it even more, then it turns into water vapor, the gas form. So thermal energy is just how much motion, how much kinetic energy each of the molecules has. So let's do another drawing. You probably remember this one from the book, where you have a box and it's just jam-packed with little molecules. Sorry, my picture isn't the most beautiful in the world, but here you have a ton of little molecules jammed in there. That's a solid. Now, it's not necessarily how many molecules. The number of molecules stays the same, but notice that they're not moving a whole lot. That's what I'm trying to represent here, okay? Now let's take a similar box, and this time the particles are a bit more spread out. They're moving around. This would be like a liquid. And the reason they're spread out, I should say, this is important, is because they have energy, okay? And what kind of energy? Thermal energy, like the energy related to heat. Okay, and then if we spread them out even more, they're all over the place. Well, that's like the gas, okay? And notice, like the ones that don't have much energy that are staying in the same place, it's not, again, more molecules. They all have the same amount of molecules, but the ones that aren't moving a whole lot stay solid, keeps its shape. Liquid, they're moving more, and they kind of stick together, but the shape doesn't stay consistent. It takes up the same amount of volume, same amount of space, but a gas doesn't have a consistent shape or a consistent volume because they're so energized. So let's think about all three of these in terms of how much thermal energy they have. So I'm going to say amounts of thermal energy. Okay, so here we'd say that the solid has the least thermal energy, but the gas has the most. All right? So that's what we're talking about. How much energy do the molecules have? Again, same number of molecules between solid, liquid, and gas, just different amount of energy. So this is thermal energy. What are the molecules doing? How much energy do they have? And as a result, what kind of state of matter are they in? And then let's bring that back over. So when we're talking about movement or transfer of thermal energy, we're talking about sharing that energy with another substance. So it's going from, for instance, from one substance to another. I should get a different color here. Let's get a different color. I guess we'll do pink. It's the closest to the sun for now. So if I have a sun, that's shining, it would have a lot of thermal energy. And let's say via radiation, it's sharing its thermal energy. And that thermal energy maybe comes down to a person. So the person could have been cold, meaning had a lower thermal energy. But when the sun ray goes to the person, that person absorbs some of the thermal energy from the sun. And as a result, the amount of energy that person increases because of the transfer here. So this is an example of heat. It's a transfer of thermal energy. That's a terrible heat. Sorry, let me try that again. Heat. It's a transfer of thermal energy from the sun to the person. And that, by the way, would be radiation. That's one type. So I'm just going to go ahead and label that radiation. That's one of 3 types. Let's look at another type of thermal energy. If we had, and you probably are going to think of this one right away, think about the pot on the stove. If you set a pot or a pan on the stove, and that's supposed to be a pan, believe it or not. There's my fire. It's sitting there, and there's a pan here touching the flames. Well, that's conduction, because heat is transferred through the flame right to the metal pan, which is a conductor. Okay, and again, the heat that was in the flame is being given to, I shouldn't draw out my arrow that big, let me get a different color, is being given to the pan here, being transferred. So that is another form. We got conduction. And the last form that we've discussed is, if we look more closely, let's say we've got a kettle here that is also sitting, let's see if I can draw a kettle. We'll just pretend this is a good kettle. If it's sitting on the stove and we got, again, flames coming up, heating it up, or a fire or whatever, we've got a cycle going on, because inside the water or whatever is inside this kettle is being heated. Again, there's a thermal energy transfer from the fire to the liquid, and as a result, let me get a different color again. I'm going to use a green. The burner, the source here, the fire, is transferring thermal energy, and the water inside is being heated. Now, the water down here close to the bottom is being heated. So as the water is heated, it becomes less dense and rises to the top, because less dense things tend to go to the top. And when it gets to the top, it gets away from the heat source, so it cools down and becomes more dense, and then returns to the bottom where the more dense water is, where it heats up again and goes back up to the top, where it cools down and goes back down to the bottom, and the cycle goes on and on. And this is referred to as convection. Now, that can happen as a gas too, like our air convects all the time, goes around in a cycle that way. So we can transfer heat in a house, hot air rises as a result of convection, all kinds of things that way. But these are the main 3 means of heat. And when we're talking about heat, it may also be helpful to think about these 3. Heat, sorry, I said this is heat. I can't believe I wrote that as heat. That should say radiation. Oh, I did say radiation. It's up here. Here's my radiation. Okay. Radiation, conduction, and convection. Oops. All 3 of these are heat, because they're a means of thermal energy transfer or movement. Now, heat you can think of as a noun or a verb. If you say there's a lot of heat in this place, it's hot, that'd be a noun. But I want you to think about it as a verb form, like we're going to heat the room. We're going to transfer thermal energy and make it more, so that it has more thermal energy. We're going to increase the thermal energy and, as a result, raise the temperature up. So let's stop and think about what's similar between heat and thermal energy. Probably the big similarity between the two, I don't know what color to use. Let's use the pink. Is that they both use energy, right? Or they have to, I shouldn't say use, let's say have to do with energy. And specifically, we're talking about thermal energy. Okay, so obviously thermal energy has to do with thermal energy, but we're really talking about movement of molecules with thermal energy. And then over here with heat, we're talking about sharing that energy. So maybe sharing would be a good word over here too, to help us make sense of it. Sharing that energy. Okay, so those are the key differences. Think of thermal energy as the molecules and how fast they're moving, how much kinetic energy they have. And then heat, again, is sharing it with something else.